Hello, in this lecture we will find the size of line segment AE. In the drawing we have square ABCD. We know that BE equals to 2 units, DE equals to 8 units, and angle BED equals to 90 degrees. It is a right angle. Angle BED equals to 90 degrees. And we want to find out the size of line segment AE. Okay. So first of all, we will join points B and D together by a straight line. Actually, triangle BED is a right triangle. So in the right triangle, triangle BED, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So that is to say, the square of the hypotenuse in triangle BED is BD squared, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to BE squared plus ED squared. So I will repeat again. In the right triangle, triangle BED, BD squared equals to BE squared plus ED squared. So BD squared equals to BE squared. BE equals to, or EB equals to 2 units, so EB squared is 2 squared, 2 squared is 4, plus DE squared. DE equals to 8 units, so DE squared is 8 squared, 8 squared is 64. So in total we got that BD squared equals to 4 plus 64, 4 plus 64 is 68. So we found out that BD squared equals to 68. So here we'll take a root out of equation number 1, and we will get that BD equals to the square root of 68 units. So we can write here that BD equals to the square root of 68 units. BD is also the diagonal of square ABCD. So in the next step, we also know that all the angles inside the square are right angles, therefore angle BCD is a right angle, it equals to 90 degrees. And angle BAD also, it is a right angle, it equals to 90 degrees. So in the next step, I will present to you new rule number 1. and we will implement rule number 1 in our drawing. According to rule number 1, the diagonals of a square bisect or cross the angles of the square into 45 degrees angles. I will read rule number 1 again. Rule number 1 states that the diagonals of a square bisect or cross the angles of the square into 45 degrees angles. So, according to rule number 1, the diagonal DB bisect angle ADC into angles of 45 degrees, that is to say, angle BDC will be equal to 45 degrees, and angle BDA will be also equal to 45 degrees. Likewise, here the diagonal DB bisects angle ABC into 45 degrees angles, that is to say, angle DBC will be equal to 45 degrees, and angle ABD will be also equal to 45 degrees. So, we will focus on the right triangle PCD. On the right triangle BCD, cosinus 45 degrees will be equal to DC over DB. I will repeat again. In the right triangle this BCD, cosinus 45 degrees will be equal to DC over DB. We will define DC as y, that is to say DC equals to y, and then we can substitute DC here by y over dB. We've already found out that dB equals to the square root of 68 units. So in total we got that cosinus 45 degrees equals to y over square root of 68. But we know that cosinus 45 degrees equals to square root 2 over 2 and all equal to y over square root of 68. Here we will multiply equation number 2 by square root of 68 and we will get that square root 2 over 2 times square root of 68 equals to y. So we found out that y equals to the square root of 2 over 2 times square root of 68. We know that 68 equals to 34 times 2, so we write it down. So y will be equal to square root 2 over 2 and instead of 68 we will write down 34 times 2. We also have the rule that states that the square root of a times b equals to the square root of a times square root of b. According to this rule, the square root of 34 times 2 will be equal to the square root of 34 times square root of 2. So in total, y will be equal to square root of 2 over 2 and times square root of 34 over square root of 2. Square root of 2 times square root of 2 is 2, so we write it down. We found out that y equals to 2 over 2 times square root of 34. 2 over 2 is 1, so 2 will get cancelled. And we actually found out that y equals to the square root of 34 units. And because of the fact that we know that all the sides of a square are equal to each other, all the other sides of square ABCD will be also equal to square root of 34 units. So y equals to square root of 34 units. BC will be also equal to the square root of 34 units. AB will be also equal to the square root of 34 units. And AD will be equal to square root of 34 units. Okay, in the next step I will present to you a new rule and we will implement the rule in our drawing. We have rule number 2. According to rule number 2, if line segment AB subtends two equal angles on the same side, then the quadrilateral ABCD is inscribed by a circle, and the 4 points A, B, C, and D lie on that circle. I will read rule number 2 again. Rule number 2 states that if line segment AB subtends two equal angles on the same side, then quadrilateral ABCD is inscribed by a circle, and the 4 points A, B, C, and D lie on that circle. So, what is the meaning of rule number 2? The meaning of rule number 2 is that if you have line segment AB so this is line segment AB, and on line segment AB there is two equal angles that rest on line segment AB. So the first angle is angle ACB rests on line segment AB, and it equals to theta, and we have also second angle that is also equals to theta, that also rests on the same line segment AB. Angle ADB also equal to theta, and it is also rests on line segment AB. So if this is the situation, that we have two equal angles that rest on the same line segment AB, then according to rule number 2, the quadrilateral ABCD is inscribed by a circle. So this quadrilateral ABCD is inscribed by a circle, and the 4 points A, B, C, and D lie on that circle. So, first of all, quadrilateral ABCD is inscribed by a circle. So there is a circle that blocks quadrilateral ABCD. So according to rule number 2, if we have two equal angles that rest on the same line segment AB, then if this is the situation, then quadrilateral ABCD, this quadrilateral is inscribed by this red circle, and the 4 points A, B, C, and D lie on that circle. So this is actually the explanation of rule number 2. Whenever you have two equal angles that subtend the same line segment, then they form a quadrilateral that it is inscribed by a circle, and the 4 points, the 4 relevant points, lie on that circle. Okay, so we can actually implement rule number 2 in our drawing, because we have in our drawing we have those two right angles. Angle BAD is a right angle, and it rests on line segment BD, and angle BED, this angle, it is also a right angle, and it is also rests on the same line segment BD. Therefore, according to rule number 2, the quadrilateral AEBD, this quadrilateral is inscribed by a circle, and the 4 points AEBD lie on that circle. So according to rule number 2, the quadrilateral AEBD in the green color, the quadrilateral in the green color is inscribed by a circle, and the 4 points A, E, B, and D lie on that circle. So the green quadrilateral is inscribed by a circle. So we will draw the green quadrilateral inside the circle, and the 4 points A, E, B, and D lie on that circle. So here we have quadrilateral AEBD that is described by this circle. So according to rule number 2, because of the fact that two right angles subtend on the same line segment DB, then this red quadrilateral is inscribed by this blue circle. So we will paint the quadrilateral in a green color, exactly like the original quadrilateral. So the green quadrilateral is described by the blue circle, and the 4 points A, E, B, and D lie on this blue circle. And we also have two right angles that subtend on the same line segment BD. angle BAD is a right angle, it equals to 90 degrees. And angle BED, it is also a right angle that subtends on the same line segment BD. So I'll repeat on rule number 2 again. We have angle BED that is a right angle that rests on line segment BD, and we have also angle BAD that is also a right angle that rests on the same line segment BD. Okay, so because of that situation, according to rule number 2, the quadrilateral in the green color, quadrilateral AEBD is described by this blue circle, and the 4 points A, E, B, and D lie on this blue circle. So that is the implementation. This drawing is the implementation of rule number 2 in the original drawing. In this original drawing, we have here two right angles that rest on the same line segment BD. Therefore, according to rule number 2, the green quadrilateral AEBD is described by this blue circle, and the 4 points A, E, B, and D lie on this blue circle. Okay, so that is the implementation of rule number 2. This is the implementation of rule number 2 in our drawing. Okay. Now I will present to you rule number 3, and we will implement rule number 3 in this drawing. According to rule number 3, if quadrilateral ABCD is described by a circle, then its diagonals, the product of its diagonals equals to the sum of the products of its opposite sides. So I will read rule number 3 again. Rule number 3 states that if quadrilateral ABCD is described by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have quadrilateral ABCD that is described by this circle, so quadrilateral ABCD is described by this blue circle. We know that side AB of quadrilateral ABCD equals to A units in its size, side BC equals to B units in its size, and side CD equals to C unit in its size, and side AD of quadrilateral ABCD equals to D unit in its size. And quadrilateral ABCD has two diagonals. Diagonal AC is equal to X units in its size, and the second diagonal BD is equal to Y units in its size. Then, according to rule number 3, whenever you have a quadrilateral that is described by a circle, like in this drawing, according to rule number 3, the product of diagonal ABC, the product of diagonal ABC, the product of quadrilateral ABC D diagonals is X times Y. Again, the product of quadrilateral ABCD diagonals is X times Y, and that product equals to the sum of the products of its opposite sides. A quadrilateral ABCD has two pairs of opposite sides. Side AD is opposite to side BC, and the second pair of the opposite sides is side AB is opposite to side DC. So the first product of the opposite sides is D times B, and the second product of the opposite sides is A times C, and the sum of the product of the opposite sides is product 1 plus product 2, that is to say it equals to DB plus AC, and the sum of the product of its opposite sides equals to the product of its diagonals. That is to say it equals to X times Y, or the product of its diagonals X times Y equals to the sum of the product of its opposite sides, that is actually DB plus AC. Okay, so we actually can implement rule number 2 in our drawing. We can implement rule number 3 in our drawing. Whenever we have quadrilateral that is inscribed by a circle, we can implement rule number 3. So we have here the green quadrilateral AEBD that is inscribed by the blue circle. Therefore, we can implement in this drawing rule number 3. And according to rule number 3, the product of quadrilateral AEBD diagonals is AB times DE, and that product equals to the sum of the products of its opposite sides. We have side AE that is opposite to side DB, and the product of those two sides is AE times DB. That is the first product of the opposite sides. And the second product of the opposite sides, it is actually we know that AD is opposite, side AD is opposite to side EB, therefore and the product of those two opposite sides is AD times EB. And the sum of the product of the opposite sides is product 1 plus product 2. That is to say, it equals to AE times DB plus AD times EB. That is the sum of the product of the opposite sides of quadrilateral AEBD, and it equals to the product of its diagonals. That is to say, it equals to AB times DE. Again, the product of quadrilateral AEBD diagonals is AE times DE, and it equals to the sum of the product of its opposite sides. It is actually AE times DB, that is the first product, plus the second product of the opposite sides, AD plus EB. Okay, so the sum of the product of the opposite sides, that is to say product 1 plus product 2, equals to the product of its diagonals, that is actually AB times DE. Okay, that is equation number 3. Equation number 3 is actually the implementation of rule number 3 in our drawing. Okay, I will repeat again. The product of quadrilateral AEBD diagonals is AB times DE, and that product equals to the sum of the products of its opposite sides. And the first product of the opposite sides is AE times DB, the second product of the opposite sides is AD times EB, and the sum of the product of the opposite sides is product 1 plus product 2, and it equals to the product of its diagonals, that is actually AB times DE. Okay, so now I will copy again equation number 3 in the new page, and we will put the data inside this equation number 3 in order to find out the size of line segment AE. Okay, so according to equation number 3, AB times DE equals to AE times DB plus AD times DB. So what is AB? The size of AB is the square root of 34 units. And what is DE? DE equals to 8 units according to what is given us in the question. So here we found that AB equals to the square root of 34 units and DE equals to 8 units. And AE is the missing line segment, so we will leave it as it is. Times DB. DB equals to the square root of 68. So here AE is AE and DB equals to the square root of 68. And what is AD? AD equals to the square root of 34 units times EB. EB equals to 2 units. I will repeat again. AD equals to the square root of 34 units and EB equals to 2 units according to what is given us in the question. So here we know that 68 is 34 times 2, so we will substitute 68 by 34 times 2 and we will not change anything else other than this change. So we'll get that square root of 34 times 8 equals to AE times, instead of 68, we write down 34 times 2 plus square root of 34 times 2 so we know that the square root of a times b equals to the square root of a times square root of b. Therefore, according to this rule, the square root of 34 times 2 will be equal to the square root of 34 times square root of 2. So this is the only change that we make in equation number 3. The rest is as it is there. Here, AE will not change the rest of the expression, only this change. Here we will divide the equation number 3 by square root of 34. So square root of 34 will get cancelled. And what is left after we cancel square root of 34? What is left? It is actually 8 equals to square root of 2 times AE plus 2. So here we'll subtract 2 from equation number 3 and we will get that 8 minus 2 is 6 equals to square root of 2 times AE. Here we will divide the equation number 3 by square root of 2 and we will get that AE equals to 6 over square root of 2. 6 equals to 3 times 2, so we'll substitute 6 by 3 times 2. We will get that AE equals to 3 times 2 over square root of 2. So here we will multiply this expression by square root of 2 and then we will divide it by square root of 2, so we will change nothing. Therefore it is allowable to do this operation. We will get that AE equals to 3 times 2 over square root of 2 times square root of 2 divided by square root of 2. So here square root of 2 times square root of 2 is 2, so we will get that AE equals to 3 times 2 times square root of 2 over 2. 2 over 2 is 1, so 2 will get cancelled. And the final answer is that the size of line segment AE is equals to either 3 times square root of 2 units, or in terms of numbers, the size of line segment AE is 4.243 units. So I will repeat again. The size of this line segment, the red line segment AE, equals to either 3 times square root of 2 units, or in terms of numbers, the size of line segment AE equals to 4.243 units. Okay, that is the answer to the question. Now I will summarize the lecture. Actually, we wanted to find out the size of line segment AE, and we have in the drawing square ABCD, and we know that line segment EB equals to 2 units, line segment DE equals to 8 units, and angle BED, this angle is a right angle, it equals to 90 degrees, and we want to find out the size of line segment AE. Okay. So first of all, we connected points B and D together by a straight line. The red straight line is also the diagonal of quadrilateral ABCD, but it is also the hypotenuse of the right triangle, triangle BED. And according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, BD square equals to EB square plus ED square. Again, according in the right triangle, triangle EBD, according to the Pythagoras theorem, DB square equals to BE square plus DE square. So DB square equals to BE square. BE equals to 2, so BE square is 2 square, 2 square is 4, plus DE square. DE equals to 8 units, so DE square is 8 square, 8 square is 64. So we found out that dB square is equals to 64 plus 4 is 68. dB square equals to 68. We took root out of equation number 1 and we found out that BD equals to the square root of 68 units. So the diagonal dB of square ABCD equals to the square root of 68 units. Then I presented to you rule number 1. According to rule number 1, the diagonals of a square bisects the angle of the square into 45 degrees angles. We know that all the angles inside the square are right angle, so because of the fact that the diagonals of the square bisects the angles of the square, therefore they create angles of 45 degrees. That is to say, this angle is 45 degrees, this angle is 45 degrees. Likewise, this angle equals to 45 degrees, and this angle is 45 degrees also because of the fact that the diagonal dB bisects the angle of 90 degrees into two equal angles. So then we focus on the right triangle, triangle BCD. We know that all the angles inside a square are right angles, so this angle is 90 degrees, this angle is 90 degrees. So in the right triangle, triangle BCD, cosinus 45 degrees equals to DC over dB. We define DC as y, therefore cosinus 45 degrees equals to DC over dB, and dB is y, so cosinus 45 degrees will be equal to y over dB, and dB, we already found that dB equals to the square root of 68. So in total we found out that cosinus 45 degrees equals to y over square root of 68. Okay, we know that cosinus 45 degrees equals to square root of 2 over 2. So square root of 2 over 2 equals to y over square root of 68. We multiply the equation number 2 by square root of 68. And we got that y equals to the square root of 2 over 2 times square root of 68. We know that 68 is 44 times 2, so we substituted 68 by 34 times 2. And we have the rule that the square root of a times b equals to the square root of a times square root of b. Therefore, we can substitute square root of 34 times 2 by square root of 34 times square root of 2 according to this rule. So we substitute that square root of 34 times 2 by square root of 34 times square root of 2, and we got that y equals to this expression. And here square root of 2 times square root of 2 is 2, so in total we got that y equals to 2 over 2 times square root of 34. 2 over 2 is 1, so 2 will get cancelled, and we found out that y equals to the square root of 34 units. Y equals to the square root of 34 units. And because of the fact that all the sides of a square are equal to each other, all the other sides will be also equal to 34 units. Then I presented to you rule number 2. According to rule number 2, if line segment AB subtends two equal angles on the same side, then the quadrilateral ABCD is inscribed by a circle, and the 4 points A, B, C, and D lie on that circle. So what is the meaning of rule number 2? The meaning of rule number 2 is that if we have a line segment AB and two equal angles that rest on that line segment AB, then according to rule number 2, the quadrilateral ABCD, this quadrilateral is inscribed by this red circle, and the 4 points A, B, C, and D lie on that red circle. So whenever we have a line segment and two equal angles that rest on that line segment, we can implement rule number 2, that is to say the two angles and the line segment creates a quadrilateral, and that quadrilateral is inscribed by a circle, and the 4 relevant points lie on that circle. And we actually implemented rule number 2 in our circle. Why? Because we have here two right angles that subtend on the same segment line DB. Therefore, according to rule number 2, the green quadrilateral AEBD is inscribed by a circle, and the 4 points AE, B, and D lie in that circle. So, because of the fact that those two equal angles rest on the same line segments, according to rule number 2, the green quadrilateral AEBD is inscribed by this blue circle, and the 4 points A, E, B, and D lie on this blue circle. Okay, so that is the implementation of rule number 2 in our original drawing. Then I presented to you rule number 3. Rule number 3 says that if quadrilateral ABCD is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have quadrilateral that is inscribed by a circle, we can implement rule number 3 in that circle, in that drawing, okay? So we have here quadrilateral ABCD that is inscribed by the blue circle. Therefore, we can implement here rule number 3, and according to rule number 3, the product of quadrilateral ABCD diagonals is x times y, and that product equals to the sum of the products of its opposite sides. And the sum of the product of its opposite sides, the first product is b times d, and the second product of the opposite sides is a times c, and the sum of the product of the opposite sides is b times d plus a times c. That is the sum of the product of the opposite sides, and it equals to the product of its diagonals, that is actually x times y. Okay? So we implemented rule number 3 in our drawing. First of all, we can implement here rule number 3, because whenever you have a quadrilateral that is inscribed by a circle, you can implement rule number 3. And we have the green quadrilateral that is inscribed by the blue circle, therefore we can implement rule number 3. In this drawing, according to rule number 3, the product of quadrilateral AEBD diagonals is AB times DE, and that product equals to the sum of the product of the opposite sides. The first product of the opposite sides of quadrilateral AEBD is AE times DB, and the second product of the opposite sides is AD times EB, and the sum of the product of the opposite sides is product 1 plus product 2, and that sum of the product of the opposite sides equals to the product of its diagonal, that is to say, equals to AB times DE. Okay? So whenever you have quadrilateral that is inscribed by a circle, like in this drawing, you can implement rule number 3. According to rule number 3, the product of quadrilateral AEBD diagonals is AB times DE, and that product equals to the sum of the product of its opposite sides. The first product of the opposite sides is AE times DB, and the second product of the opposite sides is AD times EB, and the sum of the product of the opposite sides is product 1 plus product 2, and that equals to the product of its diagonals, that is to say, equals to AB times DE. Okay, so the only thing that is left to do is to put the data inside equation number 3. Equation number 3 is the implementation of rule number 3 in this drawing. Okay, so I copied again equation number 3, and we put the data inside equation number 3. Equation number 3 says, this is the equation number 3 that I copied. AB equals to square root of 34 units, DE equals to 8 units, AE is the missing line segment, DB equals to the square root of 68 units, AD equals to square root of 34 units, and EB equals to 2 units. Then I copied again this equation number 3, and the only change that I did is I substituted 68 here by 34 times 2, and here we have the rule that the square root of 8 times b equals to the square root of 8 times square root of b. So the square root of 34 times 2 equals to the square root of 34 times square root of 2. The other things are not changed. They are as they were. This is the only change that I did here. And here I divided the equation number 3 by square root of 34, and that what is left after we divided the equation number 3 by square root of 34. 8 equals to the square root of 2 times AE plus 2. We subtracted 2 from equation number 3, and we got that 6 equals to square root of 2 times AE. We divided the equation number 3 by square root of 2, and we got that AE equals to 6 over square root of 2. AE equals to 6 over square root of 2. But we know that 6 equals to 3 times 2, so we substituted 6 by 3 times 2. And we got this equation number 3, that A equals to 3 times 2 over square root of 2. We multiplied this expression by square root of 2, and then we divided it by square root of 2, so we changed nothing. And here square root of 2 times square root of 2 is 2. So in the denominator we have 2. In total we have 3 times 2 times square root of 2 over 2 equals to AE. 2 over 2 is 1, so 2 will get cancelled, and we found out that AE equals to either 3 times square root of 2 units, or in terms of numbers, AE equals to 4.243 units. I will repeat again. We found out that AE, this red line segment, equals to either 3 times square root of 2 units, or in terms of numbers, AE equals to 4.243 units. Okay? Thank you very much.